Hello, dear student. In previous class, I discussed about the different application of Avogadro's hypothesis. I have covered the application like explanation of Gay-Lussac law of gaseous volume. Next application is the molecular formula of gases determination by the help of Avogadro's hypothesis. Next, I have also completed two problem. These are the two problem. In this class, I will explain a new topic that is your oxidation number. What is oxidation number? As per the definition, oxidation number of an atom in a compound is the number of electrons that appears to have been lost or gained during the formation of that compound. Suppose I want to take an example. Suppose I want to take NaCl molecules. Suppose I want to take NaCl molecule. For the formation of the NaCl molecule, we need sodium atom, another is your chlorine atom. All the atoms always wants to make stable electronic configuration. If you want to see the electronic configuration of sodium, then what is the electronic configuration? That is your 281. Sodium having atomic number 11 and the electronic configuration is your 281. On the other hand, chlorine have also electronic atomic number that is your 17 and the electronic configuration is your 287. Both sodium and chlorine atom are unstable because the outermost electron of sodium and chlorine are not satisfied dualete or octet rule. That is your duplet rule or octet rule. As per the duplet rule, the atom which having two electron in the valence shell are considered as stable. As per the octet rule, the atom which having 8 electron in the valence shell is considered as stable. As per the octet and duplet rules, both sodium and chlorine atom are unstable. Sodium atom always wants to stable. Chlorine atom also always wants to stable. Sodium atom always wants to stable attain the nearest stable electronic configuration that is your of a noble gas, that is your neon. The nearest noble gas to the sodium atom is your neon. Neon is a noble gas and its electronic configuration is your 28. Its atomic number is your 10. Sodium always wants to attain the stable electronic configuration of neon by losing one electron. It cannot accept 7 electron to attain the electronic stable electronic configuration of nearest noble gas, that is your argon. It have a chance to lose one electron. It is very easy to lose one electron and attain the electronic configuration of the neon noble gas. On the other hand, chlorine have also tendency to make a stable electronic configuration. Chlorine have 7 electron, so it does not want to lose a whole 7 electron from the valency cell. It have a tendency to gain one electron. So during the formation of NaCl, what will happen? So the sodium atom having electronic configuration 281, it always wants to lose one electron, that means minus electron, and convert it into Na plus, and its electronic configuration is a 28, which is similar with the electronic configuration of neon. On the other hand, the chlorine atom gain the electron which is lost by the sodium atom and converted into Cl minus ion. Chlorine having the electron configuration 287. After gain one electron, the electronic configuration is a 288, which is similar with the electronic configuration of argon. Argon having 18 electron and the electronic configuration is a 288. Remember, sodium always a tendency to lose one electron and convert it to Na plus, which is having stable electronic configuration, and that stable electronic configuration is similar with the stable electronic configuration of nearest noble gas neon. On the other hand, the electron lost by the sodium is gained by the chlorine atom, and it attain the stable electronic configuration of on argon, the nearest noble gas, that is your argon, 288. Now both Na plus ion and Cl minus ion combine to form NaCl. For the formation of the NaCl compound, the sodium atom converted to Na plus, on the other hand chlorine atom converted to Cl minus ion. For attain the stable electronic configuration, there is a loss of one electron from the sodium and there is a gain of one electron from the chlorine. As per the definition, the number of electron lost or number of electron gained is considered as the oxidation number. So for the formation of NaCl molecule, Na converted to Na plus, that means Na plus having charge, that is your plus 1. In the NaCl molecule, sodium atom have a tendency to form Na plus, that is your, it wants to make a charge of plus 1. So the oxidation number of sodium in NaCl is your plus 1. On the other hand, chlorine atom having tendency to gain 1 electron. So here the oxidation number of chlorine in NaCl ion is your minus 1. So here we can say again say oxidation number of an atom in a compound is the number of electron that appears to have been lost or gained during the formation of that compound. That means during the formation of NaCl compound, the sodium atom appears to have lost one electron and appears to have plus one charge. On the other hand, Cl chlorine atom gained one electron and appears to have a Cl minus ion. So again, I can say that in NaCl, Na plus sodium atom having the oxidation number, that is your plus 1, and chlorine atom having the oxidation number is your minus 1. Remember an important point, oxidation number can be positive, can be 0, can be negative, can be fraction. It may, so here I can say that an atom can have positive, 0, negative or fractional oxidation number. That means the oxidation number can be positive, can be 0, can be negative or fraction. Now I will discuss about what are the rules for the determination of oxidation number. It is very important. What are the rules for the determination of oxidation number? Remember these rules. First rule is the always remember this rule. The oxidation number of a substance in its elementary state is always equal to 0. That means if you want to see about the oxidation number of hydrogen H2, H2 is an atom. It is present in the element state. Here, oxidation number of hydrogen is just said to be 0. Similarly, N2 also present in the elementary state. So, oxidation number is also 0. Potassium, calcium, magnesium, all the metal atoms. Here, the metal atoms are also stabilized in their elementary state. So, the oxidation number of these atoms is considered as 0. Remember this. All the elements, all the substances which are present in the elementary state are having 0 oxidation number. This is the first rule. Next, it is very important. The second rule is very important. The algebraic sum of oxidation number of all the element in a molecule is equal to 0, and for an ion it is equal to charge of the ion. That means it. Let me explain what is the meaning of this rule. Look at that. H2 is a molecule. As per the rule, algebraic sum of oxidation number of all elements. Here two elements are present. In hydrogen, in water molecule, two elements are present. One is your hydrogen, another is your oxygen. Hydrogen, there are two hydrogen atoms are present. So as per the rule, here I can say that 2 into oxidation number of hydrogen plus oxidation number of oxygen is equal to 0. For molecule, here the algebraic sum of oxidation of all the elements in the molecule is equal to 0. That means here I can take another example. If I want to take carbon dioxide, here carbon dioxide is a molecule. Here carbon dioxide is a molecule. So here I can write down, here I can write oxidation number of carbon plus 2 into oxidation number of oxygen is equal to 0. For molecule, the total oxidation number is equal to 0. For ion, the total oxidation number is equal to its charge. Let me explain for ions. Look at that. Here SO4 2 minus ion is present. Here the charge is your minus 2. So here I can write the formula, that is your 2 into oxidation number of sulfur. Sorry, here one sulfur atom is present. So here I can write 1 into oxidation number of sulfur plus 4 into, there are 4 oxygen atom is present. So here I can write 4 into oxidation number of oxygen is equal to minus 2. Here the charge is your minus 2. Here 4 oxygen atom is present. Here 1 sulfur atom is present. Take another example. Suppose I want to think about the another ion, that is your CO3 2 minus ion. This is your carbonate ion. In this case, what will happen? 1 into oxidation number of carbon plus 3 into oxidation number of oxygen is equal to how much? The oxidation number must be equal to the charge. Here the charge is your 2 minus, so here I can write minus 2. Similarly, you can take another example also. Suppose a Cn minus ion. What will be the concept? Here I can write 1 into oxidation number of carbon, 1 into oxidation number of carbon plus 1 into oxidation number of nitrogen is equal to minus 1. Here the charge is your minus. So here I can write minus 1. This is the formula. Similarly, you can take the positive radicals. Here I have taken NH4 ion. Look at that. Here one nitrogen atom is present. So here I can write 1 into oxidation number of nitrogen plus 4 into oxidation number of hydrogen, and it is equal to with the charge. Here the charge is your positive plus 1. So here I can write plus 1. You can take other example of positive radical. Suppose take another another maybe I want to take another positive radical. What I will take? I want to saw that. Suppose think about NH2 plus. Here you can say that oxidation number of nitrogen plus 2 into oxidation number of hydrogen is equal to plus 1. The charge is your plus 1. So here you can write plus 1. Like that, like this example, you can clearly understood what is the meaning of this rule. Again, I will repeat the rule. The algebraic sum of oxidation number of all element in a molecule is equal to 0. For molecule, the total oxidation number is 0. For ion, the total oxidation number is equal to the ion. Next, move to the another rule. Third rule says thus that the oxidation number of monoatomic ion is equal to the charge of the ion. Monoatomic ion. What is the meaning of monoatomic ions? It must be an ion, maybe positive ion or negative ion. That means maybe positive radical or negative radical, and the radical must be made by one atom. That is made by one atom. For take an example, Na plus. Here it is a positive radical. Here this positive radical is made by one atom, that is your sodium, and the charge is having it, and the radical having charge plus 1. So here I can say that oxidation number of Na plus is equal to plus 1. For monoatomic ion, it is equal to charge on the monoatomic ion. Similarly, take another example, Cl minus ion. Here the charge is your minus 1. So here I can say that oxidation number of Cl minus ion is your minus 1. You can take also Mg2 plus. Here you can say that oxidation number of magnesium Mg2 plus is your plus 2. This is a monoatomic ion, but you cannot say that for such type of ions, that is your suppose I will take CO3 2 minus ion. This is not a monoatomic ion. At first, listen, it is not a monoatomic ion. It is a compound. It is a ion which is made by different atoms. That is your one is a carbon, another is your oxygen. It is a compound radicals. It having two element, three atoms. So here we cannot say that the oxidation number means minus 2. Here you can say that oxidation number of carbon plus 3 into oxidation number of oxygen is equal to minus 2. But for monoatomic, you can write down directly. Similarly, you can take another also monoatomic radical. Take suppose Ca2 plus, that is your calcium ion. The oxidation number of Ca2 plus and is your plus 2. These are the third rule. This is the third rule. Next, move to the next rule. Accept hydrate compounds. Hydrate compounds means there must be an hydrogen. You will think about the sodium hydrate, metal hydrate, that is your calcium hydrate, magnesium hydrate. You can take the hydrate compounds. As per the rule, except the hydrate compound, the oxidation number of hydrogen in all compound is plus 1. Except the hydrated, these hydrated, if you will think about the oxidation number of hydrogen in all compound, rest of the compounds except the hydrate compound, the oxidation number is always plus 1. But for hydrate ion, you can take the minus 1. For hydrogen, if you will think about the oxidation number of hydrogen in sodium hydrate, then this must be equal to minus 1, because the metal cannot be considered as the negative ions, because the metal always shows positive ion. So the metal atom must have the plus oxidation state. That is your, look at that, in NaH it is highly necessary. Sodium shows plus 1, then automatically hydrogen shows minus 1. You cannot take hydrogen as plus 1 and sodium as minus 1. In metal hydride, the metal part always contain positive charge. As a result, the hydrogen part carry the negative charge, that is your minus 1. So here I can say that except for the hydrate compound, the oxidation number of hydrogen in all compound is your plus 1. So, the oxidation number of hydrogen in metal hydride like NaH, calcium hydride, etc. is your minus 1. Next, another rule is your oxidation number of oxygen is generally minus 2. But in some compound, its oxidation number may be minus 1, plus 2, plus 1, and minus half. Look at that. How the oxidation how the oxidation number of oxygen is varied. In water molecule, look at that. If you think about the water molecule, here the oxidation number of oxygen is your minus 2. But if you think about the hydrogen peroxide, here the oxidation number is your minus 1. In case of OF2, the oxidation number of oxygen is your plus 2. In case of O2F2, the oxidation number is your plus 1. In case of KO2, RbO2, CS2, the oxidation number is your minus 2. Let me explain. Let me explain the hydrogen water molecule first. Here we can say that oxidation 2 into, look at that, 2 into here oxidation number of hydrogen plus 1 into oxidation number of oxygen is equal to 0. It is a molecule, so it is equal to 0. Here we know that the oxidation number of hydrogen is always positive except metal hydrate. So here I can say that 2 into 1 plus 1 into oxidation number of oxygen equal to 0. So here you can say that oxidation number of oxygen is your how much? Minus 2. Look at that. In water molecule, the oxidation number of oxygen is your minus 2. Let me explain in case of hydrogen peroxide. Here for hydrogen peroxide, here we can write 2 into oxidation number of hydrogen plus 2 into oxidation number of oxygen is equal to 0. Here I can again write 2 into oxidation number of hydrogen means here plus 1. 1 I can write plus 1 here. Plus 2 into oxidation number of oxygen. Our target to find out the oxidation number of oxygen. So is equal to 0. That means here I can write plus 2 into oxidation number of oxygen equal to 0. Here I can show that 2 into oxidation number of oxygen equal to how much? That is your minus 2. Here I can say that oxidation number of oxygen is your minus 2 divided by 2, that is your minus 1. If you think about the OF2 molecule, fluorine always shows the minus 1 oxidation. All the halogen elements means fluorine, chlorine, bromine, iodine, they must shows the oxidation number that is your minus 1. All these are said to be halogen elements. In periodic table, it is said to be halogen group. For the halogen group, the oxidation number is must be minus 1. It can be vary, but the general oxidation number of halogen elements is your minus 1. Now let me explain now about the OF2. If you think about the OF2 molecule, how can I write here? For OF2, I can write 1 into oxidation number of oxygen plus 2 into oxidation number of fluorine is equal to 0. Here yeah, I can write 1 into oxidation number of oxygen plus 2 into oxidation number of fluorine means that is your minus 1. Here I can write 0. Let me explain another. Here you can find oxidation number of oxygen is your how much? That is your 0 plus 2. So here you can say that oxidation number of oxygen is your plus 2. Yes, plus 2. So in OF2, the oxidation number of oxygen is your plus 2. Let me explain about the O2F2. Suppose here I want to take O2 for O2F2. Here we can say that 2 into oxidation number of oxygen plus 2 into oxidation number of fluorine is equal to 0. 2 into oxidation number of oxygen plus 2 into oxidation number of fluorine is your minus 1 is equal to 0. Here we can say that 2 into oxidation number of oxygen minus 2 is equal to 0. You can say that oxidation number of oxygen is equal to how much? That is your plus 2 divided by 2, that is your plus 1. So here we can say that in OF2 the oxidation number is your plus 2. Already I proved. In O2F2 the oxidation number of oxygen is your plus 1. Let me think about the KO2. Here I can say that oxidation number of potassium plus 2 into oxidation number of oxygen is equal to how much? Since it is a molecule, so it is equal to 0. We know that the oxidation number of potassium, remember all the alkali metal means I will discuss later. Remember all the alkali metal having the oxidation number is your plus 1. Here potassium is an alkali metal, so here I can write plus 1. Here only one potassium atom is present, so here you can write 1 into oxidation number of potassium plus 2 into oxidation number of oxygen is equal to 0. Here I can put the oxidation number of potassium, that is 1 into plus 1 plus 2 into oxidation number of oxygen, that is your 0. Here we can write 2 into oxidation number of oxygen equal to how much? That is your minus 1. Here I can say that oxidation number of oxygen is your minus 1 divided by 2. Similarly, you can think about RbO2, CSO2. In all the case, the oxidation number of oxygen is your minus 1 by 2. So here again I will read about this sentence. Again I will read this sentence. Oxidation number of oxygen is generally minus 2. But in some compound, its oxidation number may be minus 1, plus 2, plus 1, and minus 1 by 2. These are few examples I have given. Move to the sixth number rule. The oxidation number of all the alkali metal. If you think about in the periodic table, in the left side, first column carry the element like lithium, sodium, potassium, rubidium, cesium. These elements are said to be alkali metal. And remember, these elements always shows the plus 1 oxidation state. In the second column, in the periodic table, you know very well about the periodic table. A chapter will come periodic table and periodicity. In that, I will clearly explain about the periodic table. Here, the first column is the said to be alkali metal, and the second column, that is said to be alkaline earth metal. The alkaline earth metal are beryllium, magnesium, calcium, strontium, barium. The alkali metal always shows the plus 2 oxidation state. The alkali metal always shows the plus 2 oxidation state. Remember, the alkali metal shows plus 1 oxidation state. The alkaline earth metal shows plus 2 oxidation state. Look at that. In this example, KO2, I have taken the oxidation number of potassium is your plus 1 because it is an alkali metal. Here I have listed this lithium, sodium, potassium. Next rule is remember, this is very important. For alkali metal, the oxidation number is your plus 1. For alkaline earth metal, the oxidation number is your plus 2. Next rule is we know that the halogen element, sometimes before I covered the oxidation number of the alkaline earth metal. Alkaline earth metal, that is, look at that. This is fluorine, chlorine, bromine, iodine, having general oxidation number is your minus 1. Like the oxygen. Oxygen having a general oxidation number, that is your minus 2. But it shows other oxidation number like minus 1, plus 2, plus 1, minus 1 by 2. Like the oxygen atom, the halogen element, fluorine, chlorine, bromine, iodine, they have general oxidation number is your minus 1. But they shows also different oxidation state. The oxidation number of halogen atom can shows plus 1, plus 3, plus 5, plus 7. Look at the example. In HClO, if you think about the oxidation number of chlorine, then the oxidation number is your plus 1. Let me explain how the oxidation number of chlorine in HClO is your plus 1. Look at that. For HClO, I can write here oxidation number of hydrogen plus here I can write 1 into oxidation number of hydrogen. Since one hydrogen is present, one chlorine is present, one oxygen is present, so here I can write 1 into oxidation number of hydrogen plus here I can write 1 into oxidation number of chlorine plus 1 into oxidation number of oxygen is equal to 0 because it is a molecule. We know that the oxidation number of hydrogen is your plus 1. So here I can write 1 into plus 1. plus 1 into oxidation number of chlorine. Our target to find out the oxidation number of chlorine. Here I can write plus 1 into oxidation number of oxygen, generally is your minus 2, is equal to 0. Here I can write plus 1 plus oxidation number of chlorine, that is your minus 2, is equal to 0. That means oxidation number of chlorine is your how much? That is your plus 2 minus 1, that is your plus 1. That means in HClO the oxidation number of chlorine is your plus 1. Like that you can also think about the oxidation number of chlorine in HClO3. That must be plus 5. Let me explain. Look at that. If you think about the HClO3, 1 into oxidation number of hydrogen plus 1 into oxidation number of chlorine plus 3 into oxidation number of oxygen is equal to 0, because HClO3 is a molecule, so it must be 0. Look at that. Here I can say that 1 into oxidation number of hydrogen is always plus 1 except the metal hydride. So it is necessary to put plus 1. So here I can write 1 into oxidation number of chlorine. Chlorine is belongs to halogen atoms. Our target to find out oxidation number of chlorine plus 3 into oxidation number of oxygen is your minus 2. Here I can write equal to 0. Now solve this. That is your plus 1. That is your plus 1. Plus 1 plus oxidation number of chlorine plus, that is your minus 6, is equal to 0. Here I can say that oxidation number of chlorine is your plus 6 minus 1, that is your plus 5. All in that, look at that in the table, plus 5 is given. Similarly, you can also prove oxidation number of chlorine in HClO2, that is your plus 3. Oxidation number of chlorine in HClO4, that is your plus 7. Like this type of examples, you can also think about the bromine atom, HBRO, HBRO3, HBRO2, HBRO4. You all same style, like the chlorine, you will also get the same oxidation state. That means I am talking about in case of HBRO, the oxidation number of bromine is your plus 1. In case of HBRO2, BRO2, oxidation number is your plus 3. In case of HBRO3, the oxidation number is your plus 5. In case of HBRO4, the oxidation number is your plus 7. You can also think about the rest halogen atom. Next, I will move to the another rule. In binary compound of the metal and non-metal, the oxidation number of metal is always positive, while that of the non-metal is always negative. Remember, in a compound, if metal atom is present, then remember the metal atom must carry the positive oxidation state and the non-metal carry the negative oxidation state. Take an example in case of NaCl. In case of NaCl, sodium is the metal. In case of NaCl, sodium is the metal. And chlorine is the non-metal. The non-metal always carry, that is your negative. The metal carry always positive. Look at that. Oxidation number of sodium in NaCl is positive, plus 1. Oxidation number of Cl, that is your non-metal, is your, that is your negative. If you think about the another example, suppose I want to think about magnesium oxide. Here magnesium is the metal, oxygen is the non-metal. What may be the oxidation number of magnesium? The oxidation number must be carry positive, that is your plus oxidation state. And oxygen atom is the non-metal, so it carry negative. Already we know that Mg carry plus 2 oxidation number, oxygen carry minus 2. You can think other example also. AlCl3, aluminum carry oxidation number +3, chlorine carry -1. Aluminum is metal, so positive. Chlorine is non-metal, so it is negative. If look at that, if a binary compound means two atoms are present. If the binary compound are formed by the combination of non-metallic atom and the atom with a higher electronegativity is given as a negative oxidation number. In the periodic table, I will clearly explain what is electronegativity. So, so you will wait for the upcoming class, that is your periodic table and periodicity. In that chapter, I will clearly explain what is electronegativity, what is electropositivity, what is electron affinity. I will teach you in the periodic table. So for this chapter, for this class, you will only remember in HCl molecule. Look at that. In HCl molecule, both hydrogen and chlorine belongs to the non-metal atom. Both in HCl molecule, in case of NaCl, one is the metal, another is the non-metal. But in this case, both are non-metal. If both atoms are non-metal, in that case, the non-metal which having more electronegativity, that carries, that is your negative oxidation state, and the non-metal which having less electronegativity, it carry the positive oxidation state. If you think about the HCl molecule, in HCl molecule, two atoms are present. One is the hydrogen, another is the chlorine. But if you think about the electronegativity of chlorine and hydrogen, if you want to compare, chlorine having highest electronegativity, that is your so chlorine in HCl molecule, chlorine shows that is your negative oxidation state. Look at that here, chlorine shows -1. But if you think about the hydrogen also belongs to the non-metal, but it having less electronegativity, so it carry positive. Let me explain another example. Suppose you will think another example, PCl3. Sorry, you can take another non-metal, HBr. Take simple example like the HCl. Here hydrogen is the non-metal, bromine is also non-metal. In case of HBr, both hydrogen and bromine are non-metal. So, but bromine having highly electronegative as compared to the electronegativity of hydrogen. So here bromine carry the negative oxidation state and hydrogen carry the positive oxidation state. Remember, again I will repeat, in binary compound, if one is the metal and another is a non-metal, metal carry the positive oxidation, non-metal carry the negative. In binary compound, if both are non-metal, then the non-metal which having higher electronegativity carry the negative oxidation state, and the non-metal which carry less electronegativity carry the plus oxidation state. Next rule, oxidation number of the ligand in a complex can be considered as its charge. In the coordination chemistry, you will clearly, I clearly explain what is ligand. For that chapter, remember ligand are the atom or group of atom that can donate one or more lone pair of electron. Only remember this point. In the coordination chapter, we will clearly explain this. For this chapter, for this class, I will just explain few hints, but you clearly understood. You will clearly understood in the coordination chapter. Look at that. Na plus, Cl minus, Mg2 plus. These are the simple ion. These are the simple ion, simple radicals. Similarly, CO3 2 minus ion, SO4 2 minus ion, NH4 plus. These are the complex compound radicals. These are the compound radical. But if you think about the complex radical, Fe Cn6, that is your 3 minus. These are the complex radical. In this case, here Cn is the ligand, here Fe is the central atom. I will clearly explain in the coordination chemistry. So for this chapter only remember, here in here a complex radical is given AgCN2 minus. This is the complex radical here given. In this complex radical, Cn is the ligand, and Cn is a ligand are three types. One is the negative ligand, positive ligand, and neutral ligand. Here Cn is a negative ligand and it carry the charge -1. Here I have not given. That is your Cn is the radical and it carry the -1 charge. Similarly, here another complex radical is given COH2O6 plus 2. Here water molecule is the ligand and it belongs to a neutral ligand, so its charge is your 0. As per the rule, oxidation number of the ligand in a complex can be considered as its charge. Suppose I want to say that what is the oxidation number of Cn in AgCN2 minus, then you will say that is your -1, because here what is here the oxidation number of the ligand is equal to its charge. Here the oxidation number of Cn minus, that is your cyanide radical, is your -1 because its charge is your -1. Similarly, in this complex radical COH2O6, here the water is the neutral ligand. So here the charge is your 0. So here I can say that oxidation number of water in COH26 H2 sorry COH2O6 plus 2 is your 0. Here you can say that oxidation number of Ag. Here you can say that for the complex compound, that is your AgCN2 minus. In this case, you can say that oxidation number of Ag, this oxidation number of Ag plus 2 into oxidation number of Cn minus is equal to minus. Already I discussed NH4 plus, CO3 2 minus, SO4 2 minus. Already in that case, we know that clearly. Sum of the oxidation number, algebraic sum of the oxidation number of the atoms present in the molecule or ions. In case of molecule, the algebraic sum of the total oxidation number is equal to 0. In case of ion, it is equal to charge. Similarly, you can think about the another complex radical, that is your cobalt, that is your cobalt H2O6, that is your plus 2. Here one cobalt is present, so here I can write oxidation number of cobalt. 6 ligand, that is your water is present, 6 into oxidation number of water is equal to plus 2. Again I will repeat, ligand are the atom or group of atom that can donate one or more lone pair of electron. You can clearly understood in the upcoming chapter what is ligand. This is all the rules. These are the rules for the determination of oxidation number. Few rules are difficult to understand, like the last rule. For this chapter you just remember, but in the upcoming chapter you will clear and understand what is ligand and what is the complex radical. Next I want to solve the problem. Already I have solved many problems. Let me explain the extra problem. Find the oxidation number of iron in FeO and Fe2O3. There are two compound is given. One is your FeO, another is your Fe2O3. Let me explain the problem number A. Compound is your Fe. It is a molecule. So the total oxidation number is your 0. Algebraic sum of the iron and plus oxidation number of oxygen is equal to 0. Let the oxidation number of iron is your x. So here I can write 1 iron atom is present. So here I can write 1 into x plus 1 into minus 2 is equal to 0. If you will solve, then x is equal to plus 2. So here I can say that oxidation number of iron is your plus 2. But you will think about Fe2O3. Here oxidation number of iron is your x. So here I can write 2x, 2 into x, that is your 2x. Since 3 oxygen atom is present, oxygen having also oxidation number is your minus 2. So here I can write minus 2 into 3. 2x plus 2 minus 2 into 3 is equal to 0. Now solve this. 2x minus 6 minus 2 into 3 is your minus 6. So here I can write 2x minus x is equal to 0. Now 2x is equal to plus 6. Here x is equal to plus 3. So here I can write oxidation number of iron is your plus 3. Next problem. Find the oxidation number of sulfur in SO4 2 minus. Same style. You can take, let the oxidation number of sulfur is your x. Here one sulfur is present. So here I can write 1 into x. This is not plus. There are 4 oxygen atom is present. So here you can write 4 into minus 2 is equal to minus 2. Solve this. X minus 8 is equal to minus 2. X is equal to minus 2 plus 8. X is equal to plus 6. So here I can say that oxidation of number of sulfur is your plus 6. Next move to the last problem. That is your find the oxidation number of nitrogen in NH4 plus. Simply here you can write for NH4 plus. Here I can write oxidation number 1 into oxidation number of nitrogen plus 4 into oxidation number of hydrogen is equal to plus 1, because your charge is your plus 1. It is a positive radical. It carries charge is of plus 1. Now put the value. Our target to find out the oxidation number of nitrogen. So here I can write oxidation number of nitrogen. That is taken as x. You will take here x. Instead of writing that, we can write x plus 4 into oxidation number of hydrogen is your plus 1 is equal to plus 1. That means x plus 4 is equal to plus 1. Imply that x is equal to plus 1 minus 4, that is your minus 3. So oxidation number of nitrogen in NH4 plus is your minus 3. This is all about what is oxidation number and what are the rules, different rules for the calculation of oxidation number. Finally, I have carried out a few problems regarding about the determination of oxidation number. For this class, this is very sufficient. So I want to stop the class here. Thank you very much for watching the class. At last, I want to say that if you want to if you want the note of this class, then go to the description. There is a link. You will click the link, then you will get the note. Continue the YouTube video, and you will and read well, and cover the and write down the notes. Have a nice day. Thank you very much.